Hello, and welcome to Math with Asna. In this lesson, we're going to talk about conditional statements. So we're going to introduce logical reasoning, which is the foundation of geometry. We'll learn about the different types of conditional statements, and we'll talk about how to write them. Our vocabulary starts off with a conjecture. A conjecture is a statement that's based on observations that's not proven. It's just something that you observe. A conditional statement is a logical statement that consists of a hypothesis, and we usually use the letter P to represent the hypothesis, and a conclusion. We usually use the letter Q. If-then form is a conditional statement where it is written in if the hypothesis, then the conclusion. The notation for that, we would have P, which represents our hypothesis, and then a little arrow, and Q, which represents the conclusion. So P, then Q. If P, then Q. Negation. To negate something, you essentially put in the word not. So take something and you make it the opposite, you just put in the word not. If something is true, the opposite of that, it's not true. The converse, the inverse, the contrapositive, and biconditional statements. We'll talk more specific about those when we go through an example because they're a lot easier to understand when you actually work through them. We've got some postulates here that are sort of like the basis of geometry. Any 2 points, there exists exactly one line. A line contains at least 2 points. If 2 lines intersect, their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly 1 plane. A plane contains at least 3 non-collinear points. If 2 points lie on a plane, then the line containing them lies in the plane. And if 2 planes intersect, then their intersection is a line. Let's talk about writing a statement in if-then form. So our statement is, the lights won't turn on if the electricity is not working. Notice the word if here. So this part is my hypothesis or my P, and this part is my Q. I'm going to look for keywords. That keyword here is if. I'm going to write this in if-then form. So I would say if the electricity is not working, then the lights won't turn on. If the electricity is not working, that's the hypothesis, then the lights won't turn on, that's the conclusion. Let's keep using that same statement. If the electricity is not working, then the lights won't turn on. We're going to write the converse, the inverse, and the contrapositive. So our regular statement was if P, then Q. The converse is going in the opposite direction. So the converse is if Q, then P. I'm essentially switching the hypothesis and the conclusion. I would say if the lights won't turn on, then the electricity is not working. When you have a statement in if-then form, the converse of that statement is not necessarily true. If I'm looking at this example, if the electricity is not working, then the lights won't turn on. Yeah, that's a true statement. But the converse of that, if the lights won't turn on, then the electricity is not working. That's not true. There could be lots of reasons why the lights won't turn on. It doesn't have to be the electricity. So the converse of a statement may not always be true. Let's do the inverse. The inverse is the negation of the original statement. So the inverse would be not, and we use a little squiggle to represent the not, P, then not Q. Now in my statement, I already have not, right? This is not working. They won't turn on. So to negate it, I essentially take away that word not. So I would say if the electricity is working, then the lights will turn on. So I negate both the hypothesis and the conclusion, but I don't change the order from the original statement. Now, again, just like converse, the inverse won't necessarily be true. So if you've got your original statement, if P then Q, the converse and the inverse may not be true. Our last one is the contrapositive. And this is a combination of the converse and the inverse. So I'm going to switch the hypothesis and the conclusion, and I'm going to negate them. So not Q, then not P. I'm going to do both. My statement would become, if the lights turn on, then the electricity is working. For the contrapositive, this statement is always true if the conditional statement is true. Those two statements have that relationship. If the conditional statement is true, the contrapositive will always be true. For the converse, if the converse is true, then the inverse will be true. So there's two pairs here, the statement and the contrapositive, the converse and the inverse. Okay, we mentioned this before, just because a statement is true does not mean that the converse is true. However, when the statement and the converse are true, we can write what's called a biconditional statement. So essentially what this is, it's a way to write the statement and the converse without having to write out two sentences. So instead of saying, if the electricity is working, then the lights will turn on. If the lights are turning on, then the electricity is working. I can combine it into one sentence. Let's try out, if a shape has three sides, then it is a triangle. The converse of that would be, if a shape is a triangle, then it has three sides. That's a true statement. We would write our biconditional statement, choose one of those statements. I'm going to say a shape has three sides. And I could have started with a shape as a triangle. That's up to you. And this is the biconditional part. You would write if and only if. That's the part that makes it a biconditional statement. A shape has three sides if and only if it is a triangle. If you wanted, you could have written a shape is a triangle if and only if it has three sides. A biconditional statement goes both ways. That's the whole point of it. Just to recap, the converse of a statement is not always true. When the statement and the converse are both true, we can write a biconditional statement using if and only if. If the statement is true, the contrapositive is always true. If the converse is true, the inverse is always true. If you learned something, please like and subscribe and stay tuned for more videos.